So good morning, good noon, and good evening to all of you joining us for our 31st digital event. And this time we're going to be talking about mapping from space, how satellite data are changing the way that we map the world. A big shout out to Airbus for supporting the event and making it possible. I am Muthu, I'm the co-founder of Geoawesomeness, and together I have my wonderful friend, Alex.
Hi, hello everyone.
Um, That's the two of us, and we are going to be the host for the evening. And I know quite a few of you are attending the event, maybe for the first time. So this event, unlike maybe the other webinars or digital events that you have attended, is all about networking. It's all about learning new things together. So please introduce yourselves in the chat. Phil says hello to all of you. Nice to meet you, Phil. Maybe you want to share your LinkedIn profile, let everybody know where you are based out of so that they can connect with you. Maybe you want to talk about what you're working on. That's what the chat is all about. And make sure to ask a lot of questions. Our speakers are here to take all of your questions. So hello to you, Martin. Hello, Michael. Hi, Phil. I'm sure in a few seconds we will have quite a few messages from a lot of people. So yeah, there we have it. So networking, let's get going, let's connect. When we are talking about networking and connecting, a big shout out to Nikita, our new content lead. So Geoawesomeness has been working on the content for the last 11, 12 years without having somebody who actually for worked on it, not just part-time like me and Alex do. So the first time we have Nikita, you will see her LinkedIn profile in the chat in a few seconds. So you can reach out to her, connect her, let her know what you want to read more about in Geoawesomeness. For those of you who are joining us for the first time, we've been doing it for a while. This is our 31st event. Let's see how many of you are actually here for the first time. We've had more than 100 speakers, more than 16,000 participants. And like I said at the very beginning, it's all about having fun. It's all about networking, learning something new. And I see that we are already close to 100 people in the meetup today. And close to 80% of you are here for the first time. So that's really, really fantastic. A big shout out to all of you for being here and wanting to learn something new about mapping. Alex.
Yeah, and again, a big shout out to Airbus for making this event happening. Sedi, Vanessa, huge thanks for helping organizing it and supporting Geoawesomeness community. A couple of announcements. You will see pop-up or maybe two pop-ups also later throughout the event. This is the Earth observation industry survey that we're running. We are gathering data for the following month about some of the most important things that are related to people working within the Earth observation sector. And based on this, we'll be publishing a report, well, hopefully within the next 2 or 3 months, with all the insights that we've gathered. So we welcome you to take the survey and help us out gathering all the voices from the Earth observation industry. And would also like to invite you to join our next meetup next year. Also a very interesting topic. Well, maybe not as interesting as the topic of the event today, but we'll be talking about SAR data for a specific use case of offshore wind farms. So certainly, if you like this one, join us next month. And now the most important thing. As Mutu said, today we'll be talking about satellite data mapping. Particularly, we'll be focusing on the 30 centimeters data that with Pleiad Neo becomes more and more available. And more and more use cases could benefit significantly from using such data. So today we'll have Vanessa, Laurent, Melanie, Francesco, Anna, and Sirio talking about different use cases, different applications, how different organizations could benefit from using such data. And now the cherry on the top will be also this ESG or say social development aspect from Syria, talking about how World Food Programme is using Earth observation data for good. So without further ado, let us bring Vanessa to our digital stage. Mutu, if you could bring Vanessa on.
Yeah, just.
All right. So Vanessa, together with Laurent and Melanie, will be giving us an overview of Pleiad Neo and different capabilities and use cases related to this great constellation. Vanessa, are you with us?
I am. Thank
All
you,
right.
Alex. Thank you, Mutu, for the introduction. Welcome to Toulouse with my presentation.
Great. So we are leaving you right now on the stage, and no, please feel free to kick things off.
I will.
I will wait until the presentation is up and running, and then then I will also. The stage is all yours.
Thank you, Alex. Thank you, Mutu, for the introduction. Welcome to Toulouse, seen from space, with Pleiad Neo at 30 centimeter resolution. My name is Vanessa Casals, and I am Pleiad Neo Marketing Product Manager. I would like to go to the next slide. Just to let you know that I work for intelligence marketing team. Intelligence is part of Airbus Defence and Space. We are 2,000 people working globally to deliver value from data in our digitally connected world. At Intelligence, we operate the Airbus constellation, ranging from SPOT, 1.5 meter resolution, up to Pleiad Neo, 30 centimeter resolution. Radar and optic sensors are part of the portfolio, and lately our R&D team developed an HD15 product from Pleiad Neo. Let's travel to Miami Beach to have a closer view of the constellation sensor. With SPOT and its 1.5 meter resolution, we can have a large overview of a territory. With our radar sensors, we can capture any part of the world regardless of the cloud. But radar is not only the ultimate tool to image any area in the world, it is very useful to study the structures, the movements on the ground. With Pleiad and its 50 centimeter resolution, we enter the very high resolution sensors, and we can have a closer look to an area with a very interesting swath of 20 kilometers. Pleiad Neo, with 30 centimeters, enables to zoom over an area to identify more objects. And with the HD15, you can have a sharper and a clearer view of an area. Some key figures about Pleiad Neo after almost 2 years of operation. So we have 2 satellites up and running in the space, delivering 30 centimeter resolution images at 3.5 meter CE90 of accuracy with 6 spectral bands. We have imaged more than two times, well, almost 3 times the global land masses. We deliver proudly our 120 customers around the world, and we are very agile in our tasking and delivery, as we noticed a record delivery of 32 minutes after an acquisition. The high quality, accuracy, and our tasking capabilities makes possible to create high-end advanced products, such as the 3D flyover that you can see, created from 3 tri-stereo pairs, and the quad over Paris. I'll let you enjoy the visit. Here we are with the HD15 produced from Pléiades Neo at 30 centimeters, using internal algo based on artificial intelligence. HD15 does not create nor remove any information in the pixel, but the analysis, the detection, the identification are easier and more comfortable. Now that you met Pléiades Neo, let's dive into the key selling points of the sensor for mapping needs. On the mapping side, we are working with mapping agencies, land management and tax authorities, infrastructure management agencies, cities, civil engineering companies. Their need, well, of course, creating map, but very precise map, up to 1:2000 scale, enable urban mapping, prepare pre-work for civil engineering work, create 3D city models, optimize census planning, a lot of application, a lot of needs when it comes to mapping with very high resolution imagery. What is the key part of Pléiades Neo for the mapping activities? Well, obviously the 30 centimeter resolution, but not only. Obviously, having a geolocation accuracy is key to create very accurate map. And here, with 3.5 meter accuracy C90, we are on a very accurate, and we are really one of the sole actors on the market that can deliver that kind of accuracy. We have the revisit capabilities with the tasking capabilities that we have. We are very agile in our acquisition in mono, stereo, tri-stereo. The images are very rapidly available. We have 3D capabilities, as you could see with the fly through Paris. We are able to acquire and to produce massive amounts of data. And obviously, with satellites, you do not need any flying authorization to capture images over a territory. With 30 centimeter, we have new use cases such as land administration. Detection is very much easier with 30 centimeters. So we can detect illegal constructions or excavation very easily. We can do very accurate and precise urban mapping. We can contribute to smart city projects, and we can deliver very useful inputs and information to infrastructure management in civil engineering. And with also the stereo and tri-stereo, we are able to produce very precise digital elevation models. And as such, we are able to produce database for obstacles around airports and air bases. Well, this was just a quick introduction to this beautiful sensor that is Pléiades Neo. And without any further ado, I leave the floor to Laurent and to Mélanie that will speak to you about 3D.
So, hello everybody, I am Laurent Gabet. So let's just working for Airbus Defence and Space in heading the R&D team. Together with Mélanie from Dassault System, we will introduce what is a digital twin in action. So I will take care of introducing how we built it, and Mélanie will show and demonstrate how she's using it.
Yeah, exactly.
So, est-ce qu'il y a la... Okay. C'est, I guess c'est ça. Okay. Okay, so it starts from us from the satellite and the acquisition. So we have multiple satellites, as introduced by Vanessa. We are now in a digital world, so it means that our satellites are connected to the Earth, and the images are automatically downloaded on the cloud platform, and the adventure start from there. So it means that we will use the cloud platform in order to do all the processing that I will introduce just right now. Okay, so in fact, for running a simulation, we have to take care of the data. We have to prepare the data to be welcomed by the simulation engine. So we start by what introduced by Vanessa. It means processing a digital model, a 3D model. So we have an example of a 3D digital model which has been produced over the city of Aden, so in the Middle East. You can see that the result is very sharp. One important point, this is fully automatically produced from 9 Plano images. That's why we have been able to texture the walls of the building. So we create the shape of the city, and we are texturing the walls with the images which has been acquired to produce the 3D model. This is very cool. This is very nice, but in fact, it's very, very heavy and difficult for the simulation engine to use it. So we have developed another example over Paris. So quite cool. We are preparing ourselves for the Olympic Games, but you have already seen that. So we have a pipeline which is the aim of this pipeline is to simplify this model, but in fact creating a kind of CAD model which will be welcomed by the simulation engine. And this pipeline should work everywhere in the world. So the more important point are the buildings, certainly, but also you have the land use. The simulation engine should know that he's going through vegetation, trees, or there is a park, or there is a water or buildings. So we have produced that. We have to produce that. So we have developed AI engines, which you have some result. I'm presenting some result here. So we are over the city of Aden. The result that you are looking at right now are fully automatically processed for over the images. So that's quite interesting. And the challenge for us, as it should work in the same way everywhere in the world. So here you have an example over the city of N'Djamena. So you can see that it's really sandy, and even the buildings are sandy. So for us, that's a challenge to be able to extract automatically the buildings in this area, but also in the more European area. So we are in Copenhagen here, so a standard occidental city. So the process is working quite well. When that is done, we have to process the land use. So another time here where maybe you don't recognize it, but it's Manhattan. It looks like a small city when you look from the sky, but it's Manhattan. The land use is automatically produced, and it will be very helpful for the simulation. Another example over the city of Lyon. I guess, I'm not sure anymore, but I think it's Lyon, where you have the trees, the buildings, etc. When that is done, automatically we can start creating the CAD model. So that's the next step. So we have extracted the buildings, we have the land use, but we have also on the other side the 3D model which has already been produced. So we can easily affect the Z, the H to the buildings. It creates what we call the level of detail 1. So one more time, an automatic product. So this is quite light, quite cool, but may not work for any application. When you will see the simulation of the wind within the city introduced by Melanie, this is not the best product because it creates some effects on the edges of the building, and that's not welcome because there is some turbulence which are created like on an aircraft. So they need a clean representation of the roof of the buildings. So here, that's an example where we added the 3D theme, the 3D triangles over the buildings instead of having a flat roof. Okay, that's something that we are currently doing, but our goal is to have a very a kind of CTGML model. So here, the level of detail too. We are working on it. This is an automatic result, but you may look at it rapidly and you see that it's not quite perfect. So we have a PhD currently working on this subject in order to improve those results. Okay, so we have an example of Marseille of those LOD2. So we are ready. The data has been prepared and will be transferred to Melanie in order to run the processing. So Melanie, the floor is yours.
Thank you, Laurent. So yeah, Dassault system is really mainly known with Simulia for this their simulation of aeronautics and automotive domains. But here it's a new scale with our partnership with Airbus. And this new scale is the city scale. And here you have the example of Sydney. So Sydney, we simulated with two configurations. So the two main wind direction in that city. And the aim was to know the safe area, putting some pollutant emission. So two location was done. And here we have to first install the velocity of the wind through the city. And then we have to emit the pollutant in that simulation. So this pollutant could be a gas attack, a link, a chemical link, or pollutant from the train station or whatever. So here you have the representation, so a 3D representation of that emission and that propagation through the city. And we have also a slice of this representation to see the wind. And so the configuration 2 here, the volumic analysis. And so with that two configuration, we can compare and know where the wind will propagate this pollutant, and so find the area where maybe we can build a school or build an hospital, or to make some decision if there is an attack or that kind of problem. So then we have to, we can also simulate other domains. So for public services in the cities, we can simulate a heat sink. So we can also make decisions for the vegetation. We can also, at Sydney, simulate the hydrogen dispersion, but we will talk in a few slides of that city. Or also we can simulate the community noises. So in order to know if the noise from an airport, for example, can disturb the community and the people around it. But it's not the only case, the public services. We can also do that for industries. So on the top, you can see that we can simulate the antenna resistance, so the flexibility of that antenna, if there is a danger around it, or just to know his resistance. And also another example, quite realistic, is the drone. So the drone can be simulated and experimented in the wind tunnel. So wind tunnel is very specific for industry, but we don't have the real condition of the environment. And we can also do that in simulation, so put some real condition with the wind, the buildings around it, and all the thing around the drone, if to know if the flight of the drone is impacted or not. So talking to the other city, so it was Hamburg. So about Hamburg, it was a correlation case. So first we put an inert gas in the city, so in the real city. So on the left, you can see that. So the pollutant was from a boat near the river. And so it was inert, and some sensor was put in the city. And in order to compare the data, we do the same in the mockup. So in mockup, it's a reduced scale of the city that we put in a wind tunnel, so with perfect conditions. And finally, we do the same in our simulation with our tool. So we simulated the city and put the same sensors in the city to compare all of that. So here are the results. So on the left, you can see the first simulation was so the comparison between the experimentation and the simulation. So the conclusion was that the points are a little bit far away from the black line. So the black line is the perfect correlation between CFD and experimentation. And in order to fix that, we refined our case, so the setup. And to doing that, the aim was to have between 30 and 50% of the points in the tolerance interval. And so on the right, you can see that the final graphic was much better. So more than 50% of the points were in that tolerance interval. So it was a success finally. Let's go on.
Okay, thanks, Melanie. So Melanie showed you that in fact the digital simulation is as good and better, even better than the on-site measurement or mock-up simulation. So that's we have demonstrated our capacity to create a digital twin of the Earth and to use it. And this will be very helpful for decision making by in order to see how to modify, to act on the city, to add more trees or to build a bridge or whatever. So thanks for your attention. I think we are just in time. I hope, in fact. So and so the rest. Thank you.
Thank you.
Thanks so much for this super interesting presentation, and I mean the visuals were mind blowing, really. So kudos to you guys for putting things like this together. And I know that data, of course, is the most important thing, but like then how you show it to decision makers, it's also something that actually sells the idea of using satellite data for those applications, and this is still what the industry needs. So right now we've got a couple of minutes to bring up the questions for the audience. We already had a couple of people asking different things, but like let me maybe use my host privilege to ask you the first question and just to like clarify, because what you showed were a lot of different applications and use cases and products, and I wanted to make sure that it's actually clear. So Airbus, I mean, is a vendor operating at Neo Constellation and providing the data, right? But do you guys also provide the services that you presented, at least to some extent, or no, you just focus on the data and these are use cases of the use of
Of the
Play Neo
customers of the
data.
industry.
Okay, certainly we are, our first objective is to sell imagery, but we have also offers like digital elevation offers. So elevation one, or we have sorry, we have a set of offers. With Dassault, we have the goal to propose a service, a joint service, where we will acquire the image, create the model, the 3D model that we need, and propose the simulation. So it will be a bundle offer for this digital twin.
Okay, that's great. So just one ask before Mutu will start bringing up questions. So if you could then share on the chat some information if anyone from the audience would be interested to learn more about those products and services. If you could share any sort of contact details or links to how to find you guys or someone from Dassault or Airbus in relation to those amazing things that we've seen. Okay.
Thanks, Alex. So there are
Okay.
quite a few questions that are all relating to the footprint data. So let's start with the first one that Vladimir had. His question was if you've already compared the AI-based detection, which, by the way, seems to be picking up quite a lot, against the data sets that Microsoft and Google have open sourced quite recently.
Yes, so we have developed our own module, own AI module. It is based on a very massive amount of labels, building labels that we organize the digitalization. So yes, some other models are available, but we need to have something which is very specific, working in a very different condition, because an image is never so optimal as we would like. You may have some fog, you may face some clouds. Our model is able to deal with that, and also to deal with those different type of landscape. So we know the models provided by Google and Microsoft, but we felt that we had to develop our own approach.
Makes also sense because you bring the satellite imagery expertise, whereas they might be more the experts on the AI models and imagery analysis in general.
Yes, and I would like to say that lucky we are, because we have access to millions of images, and we are really taking benefit of that labeling massively, whatever we need in order to develop our models.
So the second question that was related to the building model, this time it was from Wesley, was if the system is able to classify different types of buildings.
In fact, we are splitting the block of buildings into individual buildings, because we have to provide different altitudes, different height for each buildings within a block of buildings. So yes, we have to do that, but we don't, so far, we don't provide the type of building. We don't say it's a church or it's an office building. We just provide the shape of the building, and the best we can in order to be compatible with the simulation engine. Later on, in the future, we will work on affecting some attributes to those buildings, which may be helpful for the simulation, but it will be much more like the walls are in bricks, or the walls are concrete, or the road is made on dirt, or this type of which will impact the simulation.
Yeah, because we can do that. We can put that in the simulation in order to see the.
It's quite interesting that you mentioned that it's not possible today to look into the attributes of the building, because that was exactly the question from Chris. If I give you an address, what can you tell me about the building? So this is already a product that you're working on that you are able to provide in the future.
Yes, but
Okay.
not today.
I promise this is the last question about the building model, and I translated it already. It was a question about where can they find more information about the automated building analysis. If there is some URL, maybe it would be good to share it in the chat.
Yes, we have not communicated that much on those capacities. We are selling our models, or we are using them internally, but we have not done that much publicity on those models to be sold. That's not really our strategy, but they are exposed in UP42 platform and also on the One Atlas.
Okay, then let's take a completely different question that's not related to building models, because there are quite a lot of interest in building models. Vladimir wants to know how long does it take to produce a 3D map from 9 images, from the Planetek Neo 9 images?
Okay, so in fact, our processes are getting more and more complex to be sharper and sharper. But in the same time, we have deployed our engine on the cloud. So now we are parallelizing the process. So in fact, and everything is really parallelized. We creating a piece of the cake of the city in parallel. So it depends on the energy that we are putting on, but definitively a model like Aden, I don't know, but it's something like 1 hour.
Okay, this is a bit more of a generic question, and I think maybe all of you can say your personal opinion about it. The question is, what do you think are the biggest challenges facing satellite data mapping today?
So in fact, now we are really working on the bridge between the maps that everybody is used to deal with, and it depends on the application. So when there is a very accurate mapping, then you have to follow some rules in order to achieve the goal of those mappings. And that's really a challenge, because it requires not only detecting, but it requires a kind of generalization in some cases, depending on the scale, or adapting the data to the rules, which are maybe you simplify, or maybe you connect artificially some buildings which are not, because there is some. So that's for the mapping. It's the challenge is you have to deal with multiple applications, and each application do have its own kind of rules. By example, if you use mapping for driving, you have to connect all of that in a coherent network, which is not the goal of a standard mapping approach.
Okay, that's
so
that's quite an interesting way to look at it. I did not think about the topology and the different reasons why we use satellite data. Quite interesting. Is it possible to get other opinions from the room? Because I know you have this fancy camera that rotates. Maybe one quick sentence from the other speakers as well. Wow, it's quite impressive.
Hollywood, smooth Hollywood. So yes, using satellite imagery, when you have the accuracy and the resolution that really is getting more and more accurate and more narrower to the smallest details that you can see on the ground, makes it very useful, easy to produce, easy to use in digital environment. You can produce a map from anywhere on the world, and in a very easy and digital way of using it. So really the change for mapping is there in the facility of getting information inputs and to produce the maps to make them available to a community.
Fantastic. I think we are already a few minutes over time. So Alex, do you want to invite the next speaker on stage? And thanks for a very interesting presentation.
Yeah,
Thank you.
thanks so much, guys, for this great presentation. Now let us invite Francesco to join our digital stage. Francesco from Planetek Italia will be telling us a lot about the top case studies for very high or very high resolution satellite data that they've been working on. So let me bring up your slides and let me know if
Yep, we
you
see.
see them.
Perfect.
All right.
I can see that. I can hear well. Thank you, Alex.
All right, great.
Thanks, Mutu.
So the stage is all yours.
Thank you very much. Hello, everybody. I'm Francesco Lacriola from Planetek Italia. Very happy to be here. Excited to have people from all over the world. I see the chat quite active, so it's all good. Planetek Italia is a company founded in 1994, so we are turning 30 next year. The company was created with the goal of simplifying the complexity of space. So our challenge is to provide ourselves with satellite data and give to our customers just the information, keeping the complexity of the calculation behind the scenes. Planetek has 3 divisions, so B2B for private companies, public administration for the public entities, and the space stream for all the matters related to softwares that are installed on board of satellites. Today, I am bringing a couple of interesting use cases from a couple of customers that we have. They are municipalities from Italy, and both of them have used satellite data to improve the urban management decisions. The peculiarity of these use cases is that both municipalities used 15 centimeter high definition Pléiades Neo data of new acquisition in order to tackle their challenge. So let's start with the first one, the municipality of Andria. Andria is a beautiful city in South Italy, not far from where we are located, as you can see on the map below. And the municipality is embarking on a comprehensive modernization of its railway network to enhance the urban traffic management. So since they are our customers since a few years now, we suggested them to use Pléiades Neo 15 centimeters data to tackle this ambitious project that we are about to watch. So basically, the municipality recognized the need for a major overhaul of its railway network because the existing infrastructure started to pose challenges to the urban traffic flow. In fact, the traffic flow was quite slowed down by this railway infrastructure in the middle of the city. And they were looking to make improvements to meet the growing transportation needs of the city. So their project is to take the whole railway network and station underground of the city. In fact, you can see here the rendering of the project. In order to do this activity, they needed to plan very carefully with an infrastructure engineering study the decisions, and they accepted our suggestion to do that by using satellite data. So as you can see from the picture here, they had these level barriers right in the middle of the city that were slowing down the traffic flow. And this was quite a challenge for the urban management. And this is the reason why they starting this ambitious project of taking everything underground the city. So they planned the activities thanks to the 15 centimeter Pléiades Neo data, and they could have informed decision of where to install this underground facility and all the works that they did after the approval of this new project. This is quite exciting because at the end of the new project, they will have 3 renovated urban areas with 3 new stations underground, and they will be built with the challenge of improving the sustainable mobility. So basically, to tackle this ambitious project in South Italy, the municipality of Andria turned to cutting-edge technology, so satellite data. And not only we provided them with the 15-centimeter data that were acquired in April 2023 and that we delivered a few weeks later, but we also provided them before with another Pleiad mosaic of the city in a few months before, in order to let them focus on the progress of the work activities on the ground. So they managed both to use satellite data for the infrastructure engineering project that was accepted by the municipality, and also to follow the work activities over time. And they already accepted our proposal to do that also in the following years until the end of the works. So the improvements to the railway network in Andria are expected to have a significant impact on urban traffic management. The city has more or less 100,000 inhabitants, and the optimized railway system will contribute to reducing congestion and improving the overall flow of traffic within the city. This is an overview of the 2, let's say a screenshot of the 2 satellite images we took for them. So the 50 centimeter back in 2022 and the 15 centimeter HD one in 2023, both with Pleiad data. So we were very happy about this project because the municipality recognized that satellite technology plays a pivotal role in urban development, which is something that we believe in, but now it turned more and more in reality thanks to the decision of these municipalities that are thinking in an innovative way. The second use case I am bringing is from the municipality of Venice, which is probably better known by everybody. So Venice has a peculiarity. It always, the matter of this use case is always to enhance the urban planning with the leveraging Pleiad Neo data. And the peculiarity of Venice is that the transportation takes place through the water bodies. So it's known for the intricate canal systems, and so Venice faces unique challenges in urban planning and water resource management. We can say that the acquisition of 15 centimeter satellite data provides the city of Venice with a detailed view of its transportation network and water bodies. This was used for cartographic purposes, for urban planning and land management. And another interesting fact is that we gave them access to a specific license so that they could publish the satellite image in the geoportal of the municipality, which is something required by the municipalities in Italy. We can see here an example of the geoportal from Venice, here displaying roads and the mobility aspects of the city, and here representing the utility information and cartography purposes. So as I was saying, the municipalities in Italy are tasked with maintaining updated geographic information for urban planning, construction, and land management, data open to all the inhabitants. And this high-resolution satellite data are very useful to them because of this. It fulfills this challenge. And if you think about the peculiarity of the municipality of Venice, another very important aspect is they have to preserve the cultural heritage that is present inside the city. So the municipalities are also responsible for developing urban plans to manage urban expansion, for example, but to protect the environment and, of course, preserve the cultural heritage. This is a screenshot of the image that we took for the municipality of Venice. So it is a Pleiad Neo collected in 2022 in this case. I kept for the end of my speech one very important information. The municipality of Venice receives every 2 or 3 years an aerial coverage of the municipality. And thanks to the 15 centimeter Pleiad Neo data, we were able to convince them to switch from aerial data to satellite 15 centimeter data. Saying this just because with this very, very high resolution data, nowadays it is possible to start replacing aerial data. And in particular, our customers are very happy with this, and they think that satellites are even better than aerial data because of the complete mosaic and because of the possibility of covering wide areas. Just to leave you with a taste of suspense for the future, of maybe for another appointment with Geoawesomeness. We are currently working also on another very exciting project that is related to the production of an elevation model starting from Pleiad Neo stereo data. And this is also very interesting because for the first time we are supporting a company with the executive engineering phase of an important project in Iraq. And this is a groundbreaking news because it allows us to propose also this kind of data to replace the aerial ones. So I would like to thank everybody and I leave the stage for questions. I hope I was on time. Thank you, Alex. Thank you, Mutu.
Thanks so much, Francesco. You were on spot with time, so we really appreciate it. And I mean, you've shared a lot of amazing insights and projects, which is quite outstanding because I mean, you see a lot of different academic applications of Earth observation data, but you actually don't see a lot of those projects in action. So very, very impressive and super cool. So
yeah. And as somebody who works at the railways, makes me also quite happy to see an application that brings the two worlds together for me.
So very quickly, just again using my host privilege to ask the first question. So now, out of all of those use cases that you brought up today, which one do you see having the most interest actually on the market, and which of those use cases do you see actually scaling up in terms of different cities, companies wanting to use it?
I think that the game changer to scale the use of satellite data is to always overcome over time the technical barriers, always to improve the accessibility to the data, the resolution of the data in order to have more details, the frequency of acquisition of the data, which are all things that are happening right now. I think that we are living a real explosion of all space stuff in our time nowadays. And I think that next step will be to overcome also the barrier related to the latency of the acquisitions, meaning that there is a time that passes between the satellite data acquisition itself and the receiving of this data. I think that also that is a technical aspect we can improve in order for us having the data always before, always, timely, in order to give the final information to our end users. Just think that we have a lot of engineering companies that ask today what they needed yesterday. So it's very challenging from time to time to answer them with a timely, response when satellite data are available.
I can imagine. I think also Sirio will speak about it from the perspective of the United Nations World Food Program, because the latency there really means lives. There was one Alex, do you have a question?
No, just a comment that, I mean, indeed, in one of the recent articles that I wrote on Geoawesomeness, I've analyzed that right now we've got, in fact, 12 30 centimeters satellites out there, and in 3 years it is expected, or 4 years it is expected to have 131 satellites on the orbit capturing 30 centimeters data. So indeed, the availability of such data will be amazing.
I am also reading a comment in chat, if I can just add a point from Fiona in this case, saying that using satellite data rather than aerial ones is also more environmentally friendly too. So, it feels like we are going towards an overall improvement of things. So not only from the technical point of view, in order to face challenges, but also doing that, caring about our environment.
Yeah, that's true. There was also an article about how green is satellite imagery. I will try to find it. A quick question from Wesley. His question goes more towards the satellite data providers, but I guess you have experience with it. Did you have any problems with shadows, especially in Venice?
Yes. So I wouldn't say that is a problem. I'd say that is a parameter that you have to set up, meaning that according to the time of the day that the satellite acquisition, is performed, and also the angle that is used in order to acquire the satellite images, it is absolutely possible to overcome this kind of problem, because that is an issue also that we face with our customers that are looking for detailed information from streets in narrow places like Venice, as mentioned by Wesley. But this is perfectly doable by setting the right parameters of your satellite acquisition.
Fantastic. It sounds like a matter of configuration and not really a matter of technology or capabilities.
It really is. Maybe the colleagues of Airbus can say also something more about me, but according to my experience, that is the answer.
Thanks a lot, Francisco. I'm sure there might be more questions in the chat, but with an eye on the time, Alex, would you like to invite the next speaker on the stage?
Absolutely. Thanks so much, Francesco, for a great talk. And now let's invite to the stage Anna, who will be giving us a very interesting presentation about the value of those very, very high resolution 30 centimeter satellite data from the perspective of national mapping agencies. So another very unique perspective.
Hello everyone. So
Hi.
I'm very happy to be with you today. As Alex said, I am Anna Christoffel from IGN, and I am responsible for space and Earth observation partnerships. So I'm going to tell you about how a national mapping agency is assessing the ability of Playa Neo images to meet its needs. Okay, first, a necessary presentation about IGN and its activities. IGN is a French national mapping agency. So we are a public organization under the supervision of two ministers, the Sustainable Development and the Forestry. In short, our mission is describing the territory and producing the data necessary to land and forestry management and planning. So we are quite big, with 1,600 people working on different territorial departments. And we have research units, production services, innovation and development services, and even a school, high school. So our mission is not just producing data, it's the main mission, but we also have to support the public actors in their use of geospatial data, give our expertise and assist them. And also, as I have said, teaching and research and innovation. Okay, but this presentation will focus on data. So what kind of data a national mapping agency produce? First, images. We cover all French territory by several means, and mostly plane and satellite, at a very precise resolution, 20 centimeters for aerial images, and 50 to 1 meter resolution with satellite images. We have also LiDAR coverage, so laser coverage, and we are making it on all the territory. The second kind of data is vector data and maps. Buildings, roads, hydrology, vegetation, addresses. We maintain several databases which describe the surface of the territory the most precisely possible. But this is not enough for the public actors. So we work with them, and mostly other national public actors, to produce the data they need: land cover, forestry, biodiversity, and so on. And most of this data is open source and accessible by a portal and an API. Okay, so perhaps you are thinking, okay, they cover all French territory by plane at a very high resolution, so why Planetek? Because of several factors, but mostly two: urban pressure and climate change. Territories are changing more and more quickly. Forests are suffering, even the French forests. Inundations are more and more frequent, and so on. So we need to observe the territory more frequently. And you guys talk about cost, environmental cost of plane versus satellite. So observe more frequently, use more satellite. We are facing several challenges. And to achieve these goals, we have to combine data sources. Air coverage is limited by logistical constraints, so we cannot observe the Earth more frequently by plane. And we need another very high resolution, 30 centimeters or less, with high quality and reliable data source. In short, we need another kind of images very close of the aerial images we use today. And we identify Planetek as a real opportunity for this. But how to be sure that Planetek is able to respond to our needs? We wanted to assess two things: the data quality of the images and its regularity on a large coverage, not just on few images, and the capacity of this data to be used in all data production processes. But large coverage means large amount of data, and just for assessment. So we must thank Airbus and its team, because we are working today on this subject within the framework of a very constructive partnership, where each partner brings their expertise to the other, and one objective is making the data as appropriate as possible for mapping. And without this help and this partnership, we won't have been able to make this assessment. So I won't describe all the assessment to-do lists. It will be absolutely boring. A lot of tests have had to be done, from the production of the orthoimagery to the data production, with manual methods and with artificial intelligence methods. The objective was answering three very important questions. What is the quality of PLANEO images compared to 20 centimeters aerial images? So a very hard and unequal comparison. Second, can these images be integrated in all current data production processes? Can we use them? And the third, what IT development are necessary to adapt this process? And this last question is still under reflection. So I will show you one of the tests, few of the tests we have done. So these first tests aren't very impressive. I'm sorry. Producing cartographic data without artificial intelligence, it's not very sexy, but they are crucial for us. The first step was very simple: image-to-image comparison. So you have on the right side PLANEO images, and on the left side the 20 centimeter aerial image. It was a very difficult and unequal comparison, because the resolution of the aerial images is better than the PLANEO, but PLANEO successfully met the challenge, and it was a very nice result. I chose a not very sexy place, but with a sports place, so you can see all the details, a lot of details, and all the capacity of PLANEO to show these details. And this is not 15 centimeters images, it's really 30. The second step was assessing a large coverage, because, okay, one image is of good quality, but is a lot of images are at the same quality. So we run a test on an entire department in a somewhat rainy region, not an easy, sunny region. And 50 images were acquired in a very short time, from the middle of July to the middle of October in 2022. With these images, we have produced 2 orthoimagery mosaics. So what is important is that you can buy, of course, already prepared and data to Airbus. But in our case, we need to work with raw imaging, because all data is located at a precision to 10 to 20 centimeters. So we acquire from Airbus raw images, and we made all the process of orthorectification, paving, radiometric harmonization, and all the technical treatments. And we produce two auto imagery mosaics, one in color and one using the infrared canal. And we analyze the results of this coverage and validated that each point on the image is located more or less 20 centimeters of its real position in reality. And that's a very, very good results. So it's a go to integrate our data, these images, in our data production processes. And this is the basis that permits us to make data production tests. Let's look if the images can be used to update and maintain one of our database, the agricultural plots database. IGN is in charge of to maintain this database used to monitor the European Fund for Agricultural Activities. So it's a very political subject and data we have to update in a very short time each year. There is a lot of pressure on this. We pick 40,000 hectares of agricultural areas in different places to have different kind of agricultural activities. And we compare in the same process that before, the updating with Plea-Neo images and the updating with aerial images. So on the right, you have the Plea-Neo image, and on the left, you have the aerial image. And you can see that it's very, 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 very similar. So the results are pretty good. The precision of the data is sufficient for our needs. And the people producing the data, were quite happy with these images. They enjoy the sharpness and the contrast and tell us that it was nice to work on this. Just one inconvenience, a less detailed texture of the vegetation and denser shadows than the aerial images. But we can work on that and work on radiometric adjustments. So the conclusion was that clouds should be avoided at all costs because of the cloud and because of the shadows of the clouds. The shadows are the most blocking factor because they are dense. But if there is not a lot of shadows, the images are absolutely okay for our processes. We choose to acquire the imaging between middle of April and middle of October for vegetation purpose. And we are, as a mapping agency, we need very reduced acquisition angles because of deformation and diversion that can be caused by big angles. So the next step to conclude is integrate Plea-Neo in our artificial intelligence processes. We produce and buy annotation which were delivered in September, and new experiments have begun. Fine-tuning AI models, initialization of new models, and so on. So this is to be continued and with more sexy slides. Thank you for your attention.
Thanks so much, Anna, for the very interesting overview. It was, I mean,
Alex, I think you need to adjust your mic.
how about now?
I think it's a bit better. Yeah.
So I think it's very actually difficult to compare different satellite data and with aerial data and have the right criteria and dimension to evaluate. So it's a very interesting process that you've presented. And like one thing that one observation and like a big wow from my perspective is that you guys have those capabilities to do all those tests and all those data processing internally, which is really I would say amazing and outstanding that you do all of those tests now at scale and have all of those experts and expertise inside also to work and process satellite data with that sort of analytics. So really, I mean, I'm like basically speechless a little bit after seeing what you showed. So really work.
Okay. Alex doesn't usually get speechless. He usually has a lot of questions, but since
Yeah.
he's taking a few seconds to think, I'm going to take a question from Michael. Is IGN working with Seabed 2030 to help map the oceans, or is it more of a land-based surveying focus for you?
So we are land-based of serving. There is other organization in France. We are focusing on ocean, and it's this specialization that enable us to have this expertise on data and satellite data on land, and this capacity to make these assessments. So yes, I would like to work on ocean, but no, it's not. Also,
Totally understand. Perfect. Thanks a lot, Anne. I think we are already a few minutes over time, so if you have any further questions for Anne, please post them in the chat, and I'm sure she will be able to answer it.
absolutely.
So thanks a lot. I enjoyed your presentation. Alex, up to you now for the next speaker of the evening.
So now we've got, last but not least, or as some would say, cherry on the top. We've got Sirio, who will be joining us from World Food Program. Mutu, if you can bring Sirio online. All right, here you are.
Hi everyone, can you hear me?
Yes, we can hear
Hi,
you.
Sirio.
And now we can also see your screen.
Okay.
So let us jump out of the stage, and the stage is all yours.
Thank you, Mutu, thank you, Alex, and thank you everyone for your attention. I will be very briefly try to don't follow in a sleeping effect as the last speakers. Today I want just to show you the perspective from the humanitarian side. WFP, World Food Program, is a UN agency which aims is to fight hunger. Considering the sustainable development goal is the goal number 2, zero hunger. Is an organization that is working around 85, 90 countries, and HQ is based on Rome. And this is Sirio Modugno working in the emergency division, geospatial unit. So the geospatial unit is working to try to communicate to not technical audience what is happening during a crisis or what is happening across certain territories, considering certain phenomena. Most of the phenomena that we are analyzing are environmental crises. And but of course, in the first slide, you can see not only emergency, but also we try to provide information, logistic information regarding security program, and also ad hoc mapping request. So let me try to switch to the next slide. Yep. So today we are going to speak about the emergency pillar. And I put here as an example to facilitate this this presentation the typical risk cycle, where we have a preparedness, early warning, response, and finally recovery. The geospatial unit produced the different product with a different geographic scale, and sometimes considering also remote sensing analysis. From the preparedness perspective, we have the risk analysis. So we are trying to consider, normally we don't consider remote sensing data, but we consider secondary GIS and remote sensing global data set, because we are trying to standardize across the different countries our analysis. So also the standardization is one of the features, one of the aspects that we are trying to target. And this is, in this slide, is an example of a risk methodology where we combine the exposure of a certain hazard. In that case, on the left side is an flood exposure, combined with the vulnerability information, and combined together to define the final risk. The final risk expressed in number of people that are living in the hazard-prone area and in a food insecurity condition. This methodology is used for preparedness purposes, for disaster risk reduction exercise, and understand where are the hotspot areas. Regarding the early warning and alert system, we have a standard tool that is called ADAM. I invite all you to go to this page. I will put then in the chat the address. You can subscribe and you will receive an automatic alert in case of tropical storm, flood, or earthquake. As you can see, in that case, the geographic scale is a national, overnational, or regional scale according to the extension of the phenomena. And in this case, we are considering as remote sensing data the radar information to detect the flooded areas. Regarding tropical storm, ACMWF API is our reference. Regarding earthquake, of course, US GSS is our data input. We translate this information in a standard dashboard, and we share across the user that subscribed to this service. Okay, but when we use remote sensing data, of course, we use remote sensing data particularly after a shock. This is the unfortunate case of last week Afghanistan earthquake in Herat. After ADAM alert system released the earthquake dashboard, and after to have an overview of what happened in the region, the country office asked us, okay, but which are the villages most affected? Of course, there are information that we can take advantage, like UNOSAT service or Copernicus emergency, but most of the time we have to also support the country office with some handmade analysis. And in that map you can see how we adopted a multiscalar approach from the regional to sub-district level, understanding the village, the most impacted village. Here is the typical example of the pre and post event. As you can see, the event was a disaster, and most of the village around Iraq have been affected in a dramatic way. This is another example of a post event assessment and damage assessment. Is the Libya flood crisis that interested the coast area of Libya around September. And also in that case, you can see the overview at district level is important, and then the downscaling in that case around considering the infrastructure like building and also road and bridge to report the status of the damages. And finally, considering the risk cycle phase, there is also the recovery or the monitoring exercise. This is an example in Goma of IDP camp, where we can appreciate the evolution of the IDP camp between 2021 and 2022. In that case, for the recovery analysis, we are a little bit more flexible on the data harvesting, because of course we can choose the day without cloud cover, and is a medium long term analysis in which the data availability, the remote sensing data availability is a little bit more friendly. But of course, before to close this presentation, I want to share with you the typical paradox, temporal resolution or spatial resolution, which is the best solution for a humanitarian emergency crisis description. I mean, all depend from the geographic scale. The area of interest is the trigger to understand which data we have to target. This is in this slide. I put an example for the earthquake from last year happened in Turkey and Syria, and of course the event interested two countries. It was a large event. In that case, the real asset come from the radar, the damage proxy map from the radar images, considering the level of change between the before and after the event. There is a lot of noise in this kind of products, but try to filter with a different threshold. At the end, we achieve more or less the number of people interested by this event, affected by this event. That is the real indicator that the not technical audience want to see where, how many people, where, and where these people have been affected. So before to leave the floor again, temporal resolution or spatial resolution, visible channel or radar channel. Depends on the scale, depends on the area of interest, but of course, event like cyclone, flood, landslide are all the events that the common denominator is the cloud cover. So most of the time we are going for secondary data. We are going to try to avoid this cloud cover problem and temporal resolution problem. And it seems that the radar images are the one that match more in for this medium large area of interest and for this kind of events. But of course, after the 72-hour assessment, if we have very high spatial resolution images that is covering the hotspot area, the area of interest, for us could be without any doubt an asset. So I leave the floor, and thank you for your attention. And if there is some question, I'm here. Thank you, Alex.
So much, Silvio, for this very interesting talk. One very quick question from me is about the time, right? So I guess that looking at the different applications that or use cases that you guys are analyzing and studying, the temporal resolution or getting the data basically as fast as possible within the hours perhaps after the disaster strikes it's critical. So like how do you manage to get this data as quickly as possible?
I mean, indeed, no. This comment and the previous Mutu comment hit the nail of the head. I mean, the latency. We have multiple sources, but most of the time we are trying to use secondary data to understand the probability to have certain number of people affected by the event. So the first round, when we have to return some figures like some number of people affected by the event, if we don't have the flood surface, if we don't have yet the landslide surface or the shake map, we are going normally we use probabilistic layer to understand in that area there was scenario. But in the 72-hour a shake map, flood surface, normally we are able to reach this hazard interested area, and normally we cross this hazard information with the global population raster like WorldPop or the GRC GHAs, and we return by administrative boundaries by zonal statistic the number of people according to the input that we received. So replying to your question, Alex, we try to be connected, and we try to target multiple sources, avoiding the lack, the latency effect.
So there is a hint to satellite data vendors that you guys need to be faster.
We are very welcome and very open, no, to use new data, new technology and methodologies. But of course, we have also to be pragmatic and translate the scenario in number useful to target the area that need more support.
Yeah, that's true. I can only say that I know that satellite data vendors are actually working on making things as fast as possible, and like in a specific scenario when the data is requested at a specific time, it could be even delivered below 1 hour when it comes to play at Neo. But I mean, it's I mean, with the growing number of constellations, it will be probably accessible much faster in the next couple of years. Of course, given that there is no cloud coverage, which is, as I said, one of the biggest limiting factors when it comes to optical data. But there is also a growing number of radar data on the market. So thanks so much, Sirio, for sharing with us how World Food Program works with Earth observation data and geospatial data, and you guys are doing some amazing work. So now, being conscious of time, let us maybe very quickly, wrap up. And
Thank you.
Thanks everyone for participating in this, I think, very interesting meetup. I think that we've learned a lot about satellite data mapping, a lot about very interesting use cases, a lot about things that I didn't know, and I thought I know a lot about Earth observation and mapping. Some amazing products, very useful data sources. I mean, looking at the Pleiad Neo and different 3D capabilities that are out there. So again, huge thanks for Airbus team for supporting this event. We've got Vanessa on the stage, so
Thank you, Vanessa.
maybe some last things to share from your end with the audience.
Just thank you to all the people from all around the world, and some of them with very unfortunate time difference. I'm thinking of some people from Asia Pacific. So thank you everyone for attending it. It was really great to have Planetek, Dassault, IGN, and the World Food Program speaking about mapping and satellite imagery. You can have all the information on our website, on our portal, One Atlas, that will be here for you to order and to see what is available in the archive. And anyway, we are at Airbus at your disposal if you have any further information on all the applications that are made possible by Pleiad Neo and the 30 centimeter. And thank you, Alex and Mutu, to make this event possible tonight.
Thank you.
Thanks so much. And I can say that I confirm that the Airbus team is very responsive when it comes to different discussions about different use cases. So indeed, I recommend you connecting directly and opening up discussion, because I mean the topic of satellite data mapping, I think that it's only touched when it comes to possibilities that this technology gives us. So there is a lot to be explored, and still big revolution ahead of us.
So on the big revolution ahead of us note, I also want to say thank you and have a wonderful afternoon or evening wherever you are. And thanks to Airbus again for helping us. See you, everybody. Thank you.
Thank
Bye.
you.
Bye bye.